and we'll see count hashing vectorizer. Then we look into information retrieval and then TF-IDF way of converting numbers, converting text into numbers. So with bag of words, we got one kind of capability to the data set. TF-IDF will get another. Vectorization will get another. So we will improve, right? Improve in the sense when I say improve, right? Sometimes it may be improvement, sometimes it may be not improvement also. Depends on the data set, but in general it is improvement. In terms of syntactic and semantic, right? We have started with syntactic representation. With bag of words, we started with syntactic representation. We'll move into semantic. In the process of cleaning data, you need help from regular expressions. So I'll show today, a brief overview of regular expressions, and in the real time, right, you will be using it here and there. So somewhere text processing. I changed order a little bit. The numbering is changed, but you can, once you know everything, right, you can use whichever way you want. So NLP we know, right? It's a area of artificial intelligence concerned with interactions between computers and humans, human languages. In particular, how to program computers to process, analyze large amounts of natural language data. Now, this is all complex definition. Simply speaking, natural language processing's main goal is to convert your text into numbers, right? Or try to bring out insights from the data, right? Analysis. Natural language processing, there will be analysis part also. Right? Computer linguistics is a applying computer science knowledge onto the linguistics. Right? If you say parts of speech tagging, it comes under computer linguistics. Somebody who knows language will take a novel or a Google newspaper and then tries to flag it. Computer is a noun, algorithm is a noun, right? Perform is a verb. Like linguistic is another noun. Tasks are kind of I don't know what it is, right? Like that, somebody will sit there and try to do labeling. That is called as computer linguistics. So you are trying to convert the natural language that can be processed using computers. It is not numbers. It is just that the text is there and you are trying to flag it. That is computer linguistics. Got it? Difference between natural language processing and computer linguistics. Any question? Got it, right? Okay. So now, right, we have this string, data type in Python that is pretty much useful in NLP. So I have taken pandas, numpy, and matplotlib just to check you are not getting disturbance, right? It's clear, right? Voice. Is my voice clear?
Yes, sir.
Yes.
Okay, good. So I have taken the modules there, and then I have taken a string. Kids are playing in ground. The ground is very neatly maintained. That's the string I have taken. A simple, sample string I have taken, and there is a count method. If you look into string API, right? Python documentation itself is going to be very good. At least it is. Data structures, no, it's a data type, I think. STR will be there. Yeah, here. Right, string data type. If you look into this, right, you will find all those, capitalize, case fold, center, count, encode, ends with expand tabs, right? These are all different methods. They would have added new methods also, right? Is alpha, is numeric. These methods are very useful. So I recommend you to definitely look into string data types API. Okay, built-in data types you should say. For data structures you should say data structures. Okay, count A will actually show you how many times A occurred in the string. Right, count ground also, right? It's whether it is a string or a character, it doesn't matter. It's going to count how many times it occurred. Okay, find the where exactly the word is found, right? There is no need to show all this, but if the particular string is not present, you will get -1. In interviews they may ask, right? If you use string and what happens if you don't have, you know, if the junior level guys are doing the interview, right? They'll ask these kinds of questions. Okay, so ground, right? Again at the 20th place, first time it found. And A first time 5 was at fifth index it found. The index starts from 0, right? Fifth index means sixth character. 1, 2, 3, 4, 5, sixth character. Okay, and I think so. To upper, right? We converted whole string into upper. We converted whole string into lower. This is needed, before you do any text pre-processing activity or normalization activity. This is the first step you should be doing, because if the same string, the same word is present with capitalization and small letter, the other process may consider them as two distinct words. So if you convert everything to lower, those two words will become same. That's a simple thing, but we need to remember that. First thing, case fold. You call it as case folding. So you convert everything to lowercase and then start doing the pre-processing. And title case you call this as. First letter is going to be capital and rest all are going to be small. It is called as title case. Whenever you are putting a title to any, in PPTs, whenever you are putting any title, right, you will be writing like this, right? So that is title case. You can convert to title case also if wanted, right? Show swap case. Swap case is like all the capital letters are converted to small and small letters converted to capital. See this? This title is changed to S title, and S title, swap case I did. All smalls, right? Capitals are being replaced, converted, other way around. And replace is a method which actually replaces a string or a character with the given string. So play will be replaced with sing, right? Kids are playing, singing in the ground, right? Playing was the actual word, and it was changed to singing, and the ground is very neatly maintained, right? So this replace is there in regular expression also. I'll show that sub method there. Okay, on a string it is going to be replace method, and starts with, right? Is there any, right? Is the string starts with ki? Kids are playing in the ground, right? That's the string. So ki is the starting word or characters, right? It says true, starts with, ends with, right? Is it ending with right, ending with what? Maintained, right? So if I put a ed or maintained here, it will say true, right? Like that. And ends with, sorry, it's a same thing I actually did here. So these are all the important methods that are useful, and I think we have seen this join method in initial classes of our whatever. And this is a string that we are joining this whatever word with that. So it will actually do like this r dash a, like where it's going to split this into characters and then put this whatever in between. Okay. And then is alpha num, right? Is that alpha numeric? Is alpha, is decimal, is digit, right? I don't know difference between decimal and digit. Digit is going to be integer, I think. Decimal is going to be real number. Okay. So let us take a number. What? Float object has no, sorry. Is digit is giving false. Let us look. Returns true if all characters in the string are decimal characters, right?
Sir, you have put the quotes around the two. That's why it became.
If I take out quote, right, it is not going to be string. Got it? When I took out the quotes, it is integer variable it is, and then it will not have that function. Got it? So we should have quotes there. And on string we are trying to do, right? Is digit returns true if all characters in the string are digits and there is at least one character. Okay. Okay. So API is going to be very neat. So we should have some.
Digit,
Sorry.
for each digit, you did not change S1 to num. That's why it is written false there.
Oh, okay. Sorry. Okay, that's true. Both will actually, right? This one, right? If you have 2.2. Returns true if all characters in the string are digits and there is at least one character. False otherwise. Digits include decimal characters and digits that need special handling such as uh, compatibility, supers, digits. It says like the digit will have decimal points, right? So I gave decimal point here. It should have said true. I don't know. One must be giving true, right? I don't know. We have to see this. The decimal and digit. I don't know what's happening there. Okay. So yeah, we'll see that later. E space, right? Whether the character, whatever the string we gave, is that all spaces or not, right? So if you give mhm. Heck. Yeah, I'm not changing the variable here. I'm trying to test it, right? So if there are no spaces, right, it will give false there, right? It's a blank string, there are no spaces, right? So there is another thing in Python. If it is a blank string, right? If you say yes, it will actually print blank. See that? If there is something there, right? It will actually give you true. This is a the logical expression, right? Generally, we will expect a greater than or less than or double equal to kind of an expression here. But in Python, you can put the string into if condition. If there is string, right, some string there, it will return true. If there is no string, right, it will return false. That's how it is actually working. So if you don't have like that, right, it is going into blank. If you have at least one space, it is going into the if condition, right? Got it? So this is one of the useful things in Python. Okay. That is one of the useful things in Python. So string object is useful. String object is useful. Okay, you need to look into the API and okay, and now regular expressions. So there are methods that are at the attribute level, and there are methods that can be applied onto the string directly. So give me 1 second. Okay, so there will be methods that can be applied on string. We apply match, and the resultant object we will apply group or start or end or span. Again on the string we will apply search, and the resultant whatever object, right, we can apply these. So I will show that in a moment. So I have taken the same kids are playing in whatever, right, that same string, and here I will say print yes. Right, so we have a string that is actually going into two rows. Now if I want to find, right, whether whether there is a term kids in there or not, right? So I created a regular expression, right, re compile. I compiled a regular expression here, right? I called it as p, right? Now if you look at this, match, search, find all, and find iter can be used on this p. P dot match, P dot search, P dot find all and find iter, right? That's used on directly P. The resultant object M is there, right? On M you can use group, start, end, and span, right? Got it? This is the regular expression. Right? We compiled a regular expression that can be used multiple times, right? P dot match, P dot search, whatever you want, you can do, right? On this regular expression, we used a function. The resultant object we are using group, and the resultant object we are using group or span or whatever. Okay, so what group does? So what match does, right? Define if the regular expression matches at the beginning of the string, right? Whether this particular kids is occurring at the beginning of the string we passed, right? Here we passed yes, right? This kid is occurring at the beginning. It will give you know an object m, right? When you say group, right, it actually gives you returns the matching regular expression, right? Group will give you the matching regular expression. Search scans through the string, looks for the location where this re is matching. This match will look at only the beginning. Search will actually go through whole string and tries to find where exactly the string is actually appearing, right? So I think I have examples for search also here. Okay, we'll see search. First, let us see match. I created a compile, then p dot match. There is an object. If match, right? If there is no match, right, it will give none. Let me print it. Print this match object also. Okay, so now the kids is the beginning of the string, so you will get some object here, and if that object is there, we are actually printing the result, right? Group is going to fetch you the result. If there is no result, right, we are printing none. Right? Okay, comma. Right, so match object looks like this. In match object there is a span, right? What is matched is kids. It is actually printing the result. right? This is the result. This is the match object and this is the result. So on the match object, you are applying group. You can apply span, you can apply start, you can apply end. Right? These four methods we can apply on the result. Okay. So P dot match of span, right? Where from where to where it is exactly. Span is going to give you from where to where it is occurring. This span is useful in again that what you call it as named entity recognition. Now I said that that's a problem industry is actually facing, or industry is trying to solve. You get a huge corpus of data, huge volume of data, and you need to find out named entities in there. In general, you will not be having all the named entities, right, that are needed. So you may have to get the database of named entities and then write regular expressions, find those spans, and train your model. Okay. So remember the statements I made, and when we see uh, spaCy, I'll explain you what I'm actually talking about. Okay. So you suppose that there is huge database with all the strings that you need to find, all the words that you need to find, all the phrases that you need to find. Suppose that the pre-trained model is not capable of finding them, then you should use regular expressions and find out the spans and then feed the data and the spans where it is occurring to the model so that it gets trained. Okay, we are showing that in the text from this place to this place there is a variable, this place to this place there is a variable, like that. Okay, so this span is very useful. Regular spans are useful and span is very useful. Currently in one of the projects we have to do this. I have to do this basically. Okay, so match p dot match dot span is actually going to give you where exactly the matched string is present, from where to where in the given string. Okay, that's, and then I took compile and ground I did. Right, if I say match, right, it will not give anything. See that none object, p dot match is none object. On that we are trying to do span. None object has no attribute span, right? So if you say search, right, because search will actually search through a whole string and see where exactly it is for, so it gave you the first one only. See this 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14, like to 20 only. So first occurrence of the regular expression is going to be outputted. First occurrence of the regular expression. Here I am giving words as regular expressions. You can give more complex patterns also. Right? We'll see that in a moment. Right? Now this guy is saying regular expressions and he's giving strings. No, we are going to do more complex patterns also, like this, starting with, ending with, and all that. So we started with simple strings. This is the regular expression, right? This is the regular expression we are trying to find. Here the regular expression is string, but you can give more complex expression also, right? And then we are trying to, if you want to see something is occurring at the beginning or not, match is the thing. If you want to see something is present in the string or not, search is the thing. If you want to see all the occurrences, then find all. Okay, so let me show you that also, right? So search and span, right? Search actually searched and gave you the span. So here it is giving you the match object again, right? So whether you do match or search, it will give you regular expression dot match object, which will have span and the match wherever it actually matched. Okay, any questions so far? Give me 1 second. Okay, so no questions. Good. So compile, right? Here you see I gave something, you know, in brackets. And when I give something in brackets, right, it actually looks at these three characters separately. T, R, E, right? One of these occurs, right? In the string, it will actually stop searching. So if you see this here, do we have T somewhere? Yeah, here T, right? So it's going to be like, let me take a simple, you know, I'll put K here. Kids, I here. Okay. See that? Right? It looked at, you know, it looked at this whole string and tried to take individual characters I, R, and E. Right? When I said search, right, it is going to look at the string like that, and it found I. One of those found, it came out, and you know, showing you that from 1 to 2, I occurred. Right? So if you want to print the match here, result, how can I print result? Result also I can print. Give me 1 second. Group, sorry. See that the result is actually got printed. So even if you put R first, I next, and E next, it's going to give I only. It is taking, you know, when these rectangular brackets specify that the characters inside the rectangular brackets are independent of each other. It is not string. If you just give like that, right, it will actually find the string. Okay, there is nothing found. If you give inside those rectangular brackets, it will find individual characters. Got it, right? Can I move on?
Yes, sir.
Oh, yeah. So play, right? There is a in the string, the kids are playing in the ground, but I gave only play, but still it finds. Okay, that's the power of regular expression, and it is quick. On an unstructured data, if you write regular expression, the search is going to be quick. Okay, so you can know where it is starting, where it is ending, and where it is spanning. We have seen span, group, start, end. Right, all these methods we have seen. We have seen these two methods. We are at to see find all and find iter. Okay, I'll show find all, find iter also. Start, end, right, whatever. Right, and then okay, so there is, you know, there are in regular expressions there are, I don't know what you call them as, re.I flags. Okay, basic flags. Ignore case, I don't know what is local dependence. Finds a pattern through multiple lines, right? M is multiple lines. Slash n is also there. Dot, you know, dot yes, capital S is going to find, you know, dot matches. Dot match means any character. Okay. re.u to work with Unicode data, right? Whatever we are using is Unicode data only. And re.x to write regular, regex in more readable format. Now this we need to look into. I generally I never looked into this. Re.x is going to be more useful, I think. Generally, regular expressions are very difficult to understand, right? But we have to look into re.x a little bit. Maybe if I get time, I'll look into that today. Okay, and then I'm compiling and then saying re.I, right? So if I say kids, that's going to be, right? K is capital in our string, right? K is capital, but here I gave small letter kids and then saying, you know, ignore, it should actually find, right? It found, right? It found the capital K. If I don't have this, right, did not find anything. See this in find all, it is not actually throwing error. In the search and match, right, it is throwing error because none object is returning. You know, here we are getting blank list when I do find all. Right? If I say And then ground is all small letters only. It doesn't matter whether you give regular expression or not, right? So M, no, I think this is, let me put, give me 1 second, let me take this and put it here. What I'm trying to do is, carriage return. Okay. So it's not slash R is not printing. So match through multiple lines, I don't know, right? This M and I, right? This M I couldn't find, right? Match through multiple lines, it said. Finds through multiple lines. But even without M also, it is finding through multiple lines when there are multiple lines here. I don't know what is multiple lines. Maybe put slash R here. Yeah, see this? Maybe if I put I here, it will not find. Finding. Not a big deal. I think slash M we need to see, right? Where it works. Okay, it says multiple lines, but not that much. No, maybe there is some meaning in there, but I couldn't find it. Okay, and then find all will find all the occurrences of the regular expression. Search will find the first occurrence throughout the text, but find all will find all the occurrences of the given regular expression. But find iter, it will give you an iterable object. You know, here it is giving a list object, right? Here it will give an iterable object. Either one is fine, I think. And you can actually directly loop through. Even this one also you can directly loop through. Find all, right? You can just do, you know, that's a list, right? So you can actually do that. Right? This one also you can do, right? Find iter also. It will give you a iterable object. Oh, okay. The difference is there. Okay. So here find all, right? It is giving you the group of the search, right? Group of the search. But you know, find iter is giving you total object, match object, right? It has got span, it has got, you know, match and all that, right? Find iter has got more capability, right? More information in the you know, returned whatever. Okay. You can do group, span, whatever on this X object. Find iter is a, you know, the match object. Find all is just the result. Got it? Got it, right? So I gave some regular expression and then trying to find. If you compile it like this, right, you can use it many times in your code. If you write once, right, once you write the expression, you can use it in many places. I think there is nothing. So there are 200 apples, 400 bananas in basket. I printed S3. So now right here I am using special characters here. /D/N, right? Let us look at /D first. Maybe I'll put 0 to 9. And it will get only the numbers in there. Okay. So in the brackets, if I say 0 to 9, right? This is, you know, this dash. It's going to look at only the digits. If I say A to D, right? If I say A to D, only the characters which are, you know, which are between A and D, A, B, C, D, only those 4 will be found. See that? Only those 4 will be found, right? Like that, if I say 0 to 3, only those characters will be found, those digits will be found. Okay. If I say /D, that is equivalent to 0 to 9. It will find all the digits. This is equivalent to, okay. If I, you know, inside this It is negation symbol. Inside the brackets, if I say cap, it is negation. Non-digits only. See this? There is no digit. And if you want to, if you don't want to see the /n also, right? Oh, sorry, I had to put it inside it. See that if you don't want to see /n also, all the characters inside this are ignored, right? If you want to get a, when I put 2, that's what I'm looking at. It got a space and this is also working the same way. Okay. So negation, that cap is negation. Okay, you can use /d or 0 to 9 to say that I am looking for digits or I am not looking for digits. This is not looking for digits, only characters. The outcome, right? You can actually do the join thing. I think you should take this whole thing into, right, like this. You should do. See, there are apples, there are bananas. This is the result of find all, and I use join to actually create the strings without the numbers. Sometimes you may have to eliminate numbers and things like that. Okay. So that is kind of introduction there, and I'm going to delve a little deeper. And we have seen these basic flags. We have to explore, right? I haven't written anything on these, so you can explore that. Okay. I have taken the same string, and then I kept re.s, right? Re.s. S is the find dot matches. So dot is going to get all the characters except the full stop. Okay, if you see the outcome, right, the full stop is not going to be there. Okay, so if I take out this, what happens? Let me see. I had done something here. Yeah, it is getting this /n and dot also. If you put re.s, right, it is going to get the dot and /n also. Those special characters also are getting as the output. /n is not coming. I think okay. So for with dot, right, all characters will come, but special characters will not come. If you want to add special characters also, you should put re.s. Okay, let me try to find length of it. Give me 1 second. So this S thing, right? I think special characters will be, found. I think /t. /n is the one which is, this dot is not going to find. So to find /n also, we should put that. Okay. Yeah, that /n is the one which is finding. So dot will find out, will actually an expression for all characters except /n. I forgot actually. I thought it is for dot, for except for /n. If you want to get /n also, you should put re.s. Okay. If you want to find /n also, then you should put re.s. That's the thing. And then it's raining while they are playing, so I took other string here, and then I think we have seen this, right? Regular expression re.I will actually look at the uh, ignore case. Ignore case, it's on small letters and this is on capital letters, starting with capital letters, still it found. If re.I is not there, you will get error. Right? The no match and group is not good. You cannot apply group on a none object. If you have re.I, it will actually fold the case and then try to do the search. Okay. And then re.match of playing. This we know, right? Match will look at something in the beginning of the string. The playing is not the beginning of the string, so it's not going to have. So I think I don't know why I wrote it here again. If I say playing, it will throw error. Beginning, I have explained that. Okay. Oh, maybe. So generally, right, when you do this expression, maybe you should put this if condition there to see whether there is an object of the match or not. If there is something, then you will be doing group or start or end or span on that. If not, right, you should be putting like this kind of if condition you may have to put in there. So for that I kept it. And search, right, search non-objective. So kids, A capital. Playing search. I think we have seen this. Okay. So dollar, right? The dollar symbol is used to check if the string ends with certain characters. So this is the whole string, right? Is it ending with right? So /m/r. So through multiple lines, I think I tried to experiment with a /m here. Let us see. If I don't have /m, what happens? Let's see. See that this is the thing. I think /n is not going to work there. We should have physical whatever that carriage return, right? Right. If when I don't have re.m, it didn't found the the ing form, right? This only first line it took, and it last one it found, I think. Found the last one, I think. Let me put that re.m. Yeah, it actually found the last one. When I put /m, right, it is finding all the, right. So by default, it is looking into the whole document and finding whether it is ending with that or not. But if you say /n, right, in each row, whether that expression is present or not, it is actually looking at. Got it? Now this I kind of initially I said I don't know, but I did this here. Got it? Any questions? Got this, right?
Yes, sir.
Yeah. So regular expressions generally we have to play with. I forget all the time. I forget. So I'm trying to remember here, remind myself here, and trying to explain. But this is a good introduction. We have covered most of it. Okay. So here, right, search kids end. So you'll get none because the string is not ending with kids, or if you put G also, it will say true, ending with G, not only ing, right? So playing, if you put, you get playing also. Right? Like that. Okay. So the special character, the slash, right? I was trying to play with this, and it is actually outputting like this. So there are slash E. I don't know, maybe slash E is a special character. Kids are. So I kept some special characters in this, and then I was actually trying to play with this. Okay, so let us see whether it finds dollar or not. So see, dollar also it found. Okay, special characters also it is finding. If you put like that, it is not finding it. So if you have to see that, if you have to find it as a string, special character as a string, then you should put slash in front of it. Escape sequence. Okay. If you kept inside those brackets, right? No need of escape sequence. Right? No need of escape sequence. So let me try to put it like this. Maybe it will be good to know. Right? And then we'll put like this also. Okay. So these two will actually give you clarity that these characters are special for the regular expressions, right? When you are trying to find them individually, you should put slash in front of it. Rather, it will not find. Okay, and I was playing with some slashes and all, but it was not working. So leave it. You try to do that experimentation. The cap is a negation. So we have seen that the cap symbol you use to check if the string starts with oh, sorry. So negation, when you actually put it inside brackets, if it is not inside brackets, right? Whether it starts with or not. Okay, whether it starts with or not. So I should actually do compile here and then find out. Sorry. Compile that. I'm changing the code a little bit, okay? And then right. So whether it starts with or not, it is actually trying to see. Did I give capital or small there? I think I changed this S2. S2 is starting with small k, right? Okay. So here, right, I compiled a regular expression and I am doing a find all here. Okay. So if you kept this inside brackets, right, that's going to be negation again. It will not, it will try to get all the characters which are not K I D S. Okay. See that? It brought all the characters which are not in this set. See this? In this particular string, it brought all the characters which are not in this set. Okay. Inside brackets, it's negation. Outside, it is begins with. Okay, that we need to remember. Character, character. You call it as cap. The character. Okay, got it right. So inside brackets, this dollar is a not general character, but outside it is going to tell you that ending, right? Here we have seen that if something is ending with or not, you have to see. Right? Maybe I'll put that also here. Give me 1 second. Let me try to enhance the notes a little bit. Right, whether something is ending or not, right? If you say kids, right, it will give blank because there is no this particular string at the end of this end of the total, whatever document. Okay, so this is beginning and this is ending. It will check at the end. This is at the beginning. Okay, and then I have written re.findAll dot yes. I think I should write this in compile kind of a thing. Right? Give me 1 second. Change it. Dot means all characters except /n. Right? Now I should be doing find all search list find all. No need to give this. So the previous one and this one are same, but when you write something like a regular expression, right, it's going to be useful in many places. So if I see, here if you see /n is not found, all characters, but /n is not found. If you want to find /n also, you should give that re.i, re.s. Right, now you will get /n also. Okay. So okay. And then I am actually trying to do some regular expressions here. Right? Let me try to compile. Let me try to write a compiled regular expression. So in this, right, I won the match. I said ha ha ha. This star actually going to find out multiple occurrences of the strings present in here. So let me try to do find all on the regular expression and then pass the string. It is actually taking individual characters and trying to find, right? H. Now here it found H here, it found H here, and then ha 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 thrice. Okay, it couldn't find A there. I won the match. Oh, A is there, but it didn't find A. I don't know. So okay, when you give star, right? It looks for H individually and HA, right? Like that, it's going to find multiple occurrences. It will find. If I say HA and then there are question mark and plus symbols. Plus will actually look for one or more occurrences, right? Let me try to put something like this. Let me try to take this and try to write another example where you will not have A or H, right? Right here there is no H or HA. See that? Right? It looks at H. Sorry, I put. See that? It tried to find H first. It couldn't find individual, zero H, no H's, and HAs are not there. But if you put plus here, it is actually trying to find one or more, and one or more is also not there. But if you put here, see that it is actually trying to find one or more H's, right? If you put HH here. Sorry. Give me 1 second. Rest is like, no, you put only one or more. Okay. Star is going to be 0 or more. Right? If you take out this, right? See that the difference? Do you see the difference there? If you put star there, right, it is actually trying to look at individual, in the order in which we have given H, HA it is trying to find. There are H's there, so it is actually bringing them out. But if you put plus, right, exactly what the string is given, it is trying to find, one or more occurrences. Okay. Even if you don't have H's in this, right, it will give you blank string. Okay. That's common for both, 0 or more occurrences is the star, plus is 1 or more occurrences. Did you see the difference there? Did you saw the difference there between 0 or more occurrences and 1 or more occurrences? Any questions? Any questions?
No, sir.
So when you compile a regular expression, you can use it many times, but when you are actually putting it into find iter or find all like this, right, you can use that there only, right? That's the difference between compilation and one more thing. If you are trying to do this multiple times, right, processing power will be, it will take more processing. If you compile it once, right, using it multiple times, it's going to be easier for the processor. The expression is already there, it's going to use it. Okay. So I already explained plus and whatever. And there is another thing, braces, right? If you put braces, it will actually try to find that many number of times. M comma n comma m, minimum n and maximum m. So search for a, right? Minimum once and maximum thrice. If I put, there is no object, right? How many? I am actually trying to see a in the string, but there is no a, only a is there, so one a is there, so it actually gave. Let me put ha. Where is yes? Yes, not s, right? Okay. Oh, this is there, right? At least n and at least m repetitions. 1 comma 3 should work. Let me take this string again. Yeah. Okay, maybe it took the wrong string there. Okay. It is set, right? That's where it is actually find all. Find all will give you the result, right? So there is no group. See that? But if I put 1 comma 6, right? So minimum once and maximum this many times. How many times it occurred? This particular block it blocked and it had actually gotten this particular block. If I say find iter, no, I'll actually kind of. See that the matches. See from 1 to 4 there is A. From 9 to 14 there is 5 A's. Okay, so it's like you got the gist, right? So this brackets will give you the minimum and maximum occurrences you can actually find. Minimum this many number of times and maximum that many number of times. Okay. So if I say 1 comma 1, what happens? Let us see. See that? Or 1 comma 1 will give you same result. Right? How many times A occurred? Right? 2 to 3, 3 to 4. Right? Whole thing. Got it? See here in this, this is kind of a, the maybe, so I am trying to search where exactly the 2 digits happen, 2 to 6 digits happen. So that's the expression here. So these are the digits, at all digits. I can say slash D also. So let me execute that. Result is 1 to 6 and whatever that number. If I say slash D here, the same result will come. Okay, in brackets, whether you give 0 to 9 or slash D, it's going to be same. Okay. So alternative, right? This the pipe symbol is going to be alternative. Okay, either this or that. So here AEC, BEC, A. That's some string I have taken. Right? I wanted to search for A or B. Right? It is like see that the same result will come. A or B or this in brackets. It's going to give same. But there is an advantage there. If you say B or A, still it is giving A, right? It is exactly equal to the brackets. Right? Find all, right? If you say see that this one and that one are same. Okay, you can do this way or that way. Okay, so grouping, right? So you can actually group. See this here, A or B, AEC or BEC you want to find. Where exactly this A or B is occurring with EC you want to find. Right? Find iter will give you actual no. In for loop I will put it. Right, so from 0 to 3 you have AEC, from 3 to 6 you have got BEC, right? So we are actually finding, right? Find all will give you only that, let me print that also, you will see the difference here. See, it is giving that only A and B, whether they are occurring together or not. That's what it is actually saying. But find iter is giving you exact match object AEC and BEC. Okay, you can do this, sir. Like that also, right? R symbol, right? R symbol will work like. But in if you have a string like this, let me try to put it in a different way. Pipe symbol, right? When we already have this what you call it as the brackets, right? Y pipe symbol, right? So you wanted to do ARBR, okay? ARBR, AREC, BREC, okay? So here, if I give ARBR, see that REC only it is finding, right? If you say no, this expression, right? Let me comment this out. See this AREC, BREC found. The difference between this brackets and this one. When you put brackets, right, individual characters will be taken. When you have multiple characters that need to match with other multiple strings that need to match with other strings, right, you should definitely use grouping. Got it? Got it? Right. So the last expression I used is /b. What is /b? Opposite to normal b. This /b matches with the specified characters are at the beginning of the string. We have multiple things to do the same thing, right? If you say like that, oh, okay, beginning of it, okay, right? So if you say, right, let me try to put foo here. Then it found, right? And then if you say /b, right, it is going to be same, right? The cap or /b are going to be same, okay, right? And then if you put capital B, right, it will find non-beginning characters, right? It will skip that first one and go to the middle of it. If you use search, right, it is going to look for the first one which is occurring. Find iter or find all will find all the occurrences, but you don't want the first one. You want to catch the next one. Then you actually have to, maybe I'll put a foo at the end also. See that it actually found the second one, right? It ignored the first one, took the second one only. Last one also. It will see this, that it is not the first one. That's the thing. /b. So you can use all these expressions there and play with it. I actually refer to this particular article and try to come up with whatever I have came up, right? So you need to practice. This regular expressions, right? I look at it every 6 months in once, right? So to actually give a class, deliver a class, so I forget and then I try to remember, right? Remind myself and things like that. But if you practice regularly, right, you'll remember well. When the project is, project needs it, right? Anyway, we'll learn, right? So that's how we do it. So that's about the regular expressions, and they are useful in projects and in interviews also. In some of the interviews, they're asking us to write code, right? Write some code on the using regular expressions, and they'll give some text and try and ask us to pre-process it and kind of build a model and things like that. So it will be useful. Okay.